All right, second type of distribution we're going to look at in section 3 here is what we call a geometric distribution. Differs just a little bit from a binomial. What's the difference is with binomial, again, we have a set number of observations. With geometric, we record the number of trials until a particular outcome occurs. Or in other words, what we're looking for is what's the probability my first success happens on a specific trial. So we go through, and if you remember, it was bins, the binomial. Okay, with geometric, it's bits. Okay, so B is still for binary. Do we have success and failure? I is still the idea of independence. Okay. S is still my probability of success. Again, we'll call it P. Okay, but the T is what's different. Okay, and when did I get my first success? So what's the probability something happens, my first success on my first try, on my second try, so on and so forth. Okay. So one thing that's also a little different here is that with a geometric random variable, my probability distribution, my table with you. Okay, with binary, remember we always started at 0, okay, because we could have 0 successes. With the geometric distribution, we're looking for my first success. So what I'm looking for is the probability my success happens on my first try, my second try, my third try. And theoretically, we could go on to infinity. Okay. So like binomial, it is important to be able to distinguish situations in which the geometric does and does not apply. So we're going to have some formulas and some different things we can use with the different distributions. We have to make sure we have those distributions first. So, situation is an activity. It says random variable interest in the game is the number of guesses it takes to correctly identify the birthday of one of your teacher's friends. What's the probability the first student guesses correctly, the second, the third? What's the probability the K student guesses correctly? Okay, number 1, verify it's geometric. So a success here would be they guess correctly. Failure not correct. Okay. We would assume each student is independent in terms of their guesses. Okay. We are looking for the first success. The probability that you guess correctly is 1 out of 7. Okay. So, we start breaking it down and looking at how do we calculate these probabilities. The probability that I'm correct on my first guess would be 1/7. Okay. Say that teacher's birthday was on Wednesday. Okay, there's 1 day out of my 7 that's correct. Probability that we get it, the second student is the first person who guesses correctly, means that they were incorrect on their first guess, but then correct on their second guess. Okay, so the probability incorrect was 6, actually not their first guess, but the first one was incorrect, so 6 out of 7 days that they had to choose from, and then 1 out of 7. Now if we go with 3, the third student being the first person who guessed correctly, and that means the first 2 were incorrect, and the third one was correct. Now, the thing to notice here in all these situations is that each time the probability of success happens once. Okay? Because we're going until we get our first one. So every guess or every trial prior to our successful one is going to be an incorrect or a failure. Okay, so that's going to help us build this formula. We're going to only have 1 success every time. Now, here I had 1 failure, here I have 2 failures. So your probability of failure, okay, if we're looking at does my first success happen on the Kth trial, okay, it's always going to be 1 less than the number of trials. So for instance, if it was the 4th student who was the first person who successfully guessed, that meant that we had 1 success, my 4th student, and then we had 4 students minus the 1 that was successful, or 3 students that are wrong. So it's quite an easy formula actually when we get to geometric. And that's where they actually show it. If y has a geometric distribution, probability of p success, possible values of y are 1, 2, and 3, dot, 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 meaning we can go on forever. Okay, it's any one of these values, there's your probability. Failure. One less than the number of trials. And only one success. Because again, we're looking for my first success, we're not looking for multiple successes. So here's your probability distribution in an example of a geometric situation. And this will happen in every one of our geometric situations. We will always be skewed to the right. No matter what my probability of success is. Okay? It's most likely to occur in the first trial. Because if we look at, again, that idea back here with the guessing correctly, 1/7 was probably a success on my first trial. Second trial, if I start with that 1/7 again, because I'm going to have one success, but if I had one failure, now I'm going to take part of that. Then I'm going to take part of that, and then I'm going to take part of that. So it keeps getting smaller and smaller as we go along. Okay, so they just kind of go through and talk about this again, is the skewed right distribution in terms of our shape. Okay, our center, our mean, okay, we'll talk about that in a little bit, how we calculate that, but we would expect in this example, again, my mean to be 7, because we would assume that with 7 days in a week, that 7 guesses, somebody would get it right. Okay? Your standard deviation, we'll talk about that as well in a little bit here. All right. So here's our expected value, okay, or our mean. Again, remember, how many times would we expect to have to do something to guarantee a success? How many times would I have to flip a coin to guarantee that I want to see heads come up? Okay? And it's very simple. 1 divided by your probability of success. Okay? So, with the example for guessing the birthdays, 1 over 1/7. Do our mathematics, we get 7. Okay? Like I said, I would expect that within 7 guesses, I would have it right, because that would mean I would guess every day of the week. Okay? Just like with a coin, there's 2 outcomes. I would expect in those 2 outcomes that I would guarantee myself flipping a tails. 1 divided by 1/2. The other thing is, really what you're looking at is your reciprocal of your probability. Okay? Now, we didn't include the formula for standard deviation because it's difficult to explain and does not appear on your AP Stats syllabus. Okay? This is what the formula is. Okay? Square root of 1 minus p over p squared. Okay? Do not worry about it. Okay? You will not be expected to find it. So that's going to wrap up section 6.3, our binomial and our geometric distributions. Good luck.